Today in class we focused on perfect squares. We looked at different size squares. You use a geoboard and some rubber bands to figure out the area of certain squares. So for homework today we're just trying to review what it is that we did in class. Number one, it says, how could you prove that this figure is a square? Well, to my knowledge, a square means all four sides are equal. So if I were to count these pegs, I have 1, 2, 3, 4, 5, 6 on this side. 1, 2, 3, 4, 5, 6 on this side. 1, 2, 3, 4, 5, 6 on this side. 1, 2, 3, 4, 5, 6 on this side. And remember, it's important not to just count the points. You're actually counting the lines in between the points as your unit. So if I were to draw lines across all of the points and connect them, I would see different units for my area. So how could we prove that this figure is a square? All the sides have the same length. Then it asks, what is the side length of the square? And luckily we already counted that, so go ahead and fill that in. Then it asks, what is the area? So if we know the area, we know that it's length times width. But for those of you who don't remember, well, you can connect all of the dots and you can draw out the squares and pretty much count the squares. But of course we want to save some time, especially if we're taking that test. We're going to just go with 6 times 6, and that gives me 36 square units. And since it's area, you don't want to forget the square, otherwise it will be marked wrong. Number 4, how could you find the side length of a square if you know the area but you don't have a geoboard? So let's say that I didn't draw this out. How will I know what the side length is of my square if I just know that it's 36 square units? Well, I know that 36, if it's a square, both of these answers multiplied together, my length and my width, have to be exactly the same. Since it's a square, all the sides have to be equal. So I know to my knowledge that it's going to be 6 and a 6. Or in other words, I could do square root of 36, which gives me 6.